Remember learning math facts? Time test, flashcards, anxiety, tears, sweating around the world. You were afraid you were going to be called on. We're going to change our focus. We're going to try to address math facts with games, families, sitting around a table, playing and actually enjoying the process of learning math facts. But first, we're going to look at what research tells us is the best way to help kids go from counting to recall. And sometimes we don't make sure that we hit all those phases. So what are those phases? How can we address them? Right now we have kids memorizing addition facts, subtraction facts, multiplication facts, division facts. They don't know how they relate. So we're going to look at how can we reason and pick facts that are hard for us and use strategies to help us figure them out. So we're going to talk today about different strategies we could use. We're going to take a little bit of a different approach based on the research from Arthur Borody. Arthur Borody recommends that we use more of a guided instruction approach. He broke the fact process into 3 phases. And in his first phase, we're going to look at counting. So the counting strategy usually comes when the concept is taught: addition, subtraction, multiplication, or division. And the initial counting strategies are either using fingers, objects, whatnot. We need to move from those counting strategies to what we call looking for relationships between numbers. We're going to refer to this as reasoning, or phase 2. And phase 3 moves us into our recall, or our mastery stage. The problem is, in the United States, we too often go from phase 1, learn the concept, to phase 3, memorize it. And we skip phase 2. So what are some things that we could be doing in that reasoning phase, that phase 2? First, we have to know when to move kids from phase 1 to phase 2. And you can see here on the screen, phase 1, the counting would move to phase 2 when in addition a student can count on. In multiplication, when students can see groups and say 2 times 2 is related to 2 times 3 because it's just one more group of 2. In multiplication, when kids can decompose or break apart numbers. When they're at that point, you're going to move to phase 2. Let's now talk about those reasoning strategies that occur in phase 2. With addition, one strategy is counting on. What would problems look like in counting on? I'm just going to pull up a board now to work on to show you these different strategies. The first strategy, count on, will occur when kids count on by 1s, 2s, and 3s. So problems such as 2 plus 1, we would expect them to count on from the larger number. Or problems like 8 plus 3. They can visually see 8 and they could count on 9, 10, 11. The count on strategy should stop after plus 1, plus 2, and plus 3. When we get to plus 4, counting on isn't an efficient strategy. The next strategy would be called make a 10 with addition. Make a 10 is probably one of the most important strategies because of our place value system. The use of 10 frames is really important in the make a 10 strategy. We want kids to see things like 8 plus 6, and they could make a 10 by breaking the 6 into 2 parts. So here a student would say 10 and 4. With a problem like 9 plus 5, a student can see the 9 is close to a 10 and make a 10 by the 10 and 4. So the make a 10 strategy goes with addition. The use of a 10 frame, really important. The next strategy, which we'll refer to as the count over 10, would be like 8 plus 6, where you know the product is over 10. Yes, we just use that with a make a 10 strategy, but in visualizing counting, some teachers refer to it as the arrow method. And so you may see students go 8 and 2 more, I'm at 10, and then 4 more, I'm at 14. This strategy is not very popular in the United States, but high-performing countries use this strategy as one of their primary strategies for figuring problems in addition out. We can extend this as we get to higher or bigger numbers, double-digit numbers, where we would say 58, add 30, and we're at 88, add 2 to get us to 90, and then 4 to get me to 94. So the make a 10 or the over 10 strategy, or the arrow method here, is one strategy that kids can do, writing it down and then later visually breaking that number up over 10. The last strategy for addition is the idea of doubles. Doubles come easy for kids, so we help them see how 6 plus 6 relates to 6 plus 7. We use doubles plus 1 or even doubles plus 2. So we help kids see that 6 plus 8 is the same as 6 and 6, which I know is 12, and then add 2 more. Our goal is to use something that they feel comfortable with to figure out something that they don't know. These are some of the addition strategies that you can use during that reasoning stage, or how Art Borody calls that the phase 2. The next strategies we're going to look at involve subtraction. So in subtraction strategies, subtraction is harder for kids than addition. We're going to look at think addition. What do we mean by that? 8 minus 5 equals question mark. When we think addition, we say 5 plus what number would give me 8? Since addition is friendly for us, we can think addition with a subtraction problem. The down over 10 method is again one of those not very popular methods in the United States, but it would be where we would have something like 14 minus 5. We'd help kids see 14 minus 4 is easy, and I'm at a 10. And then subtract 1 more, I'm at a 9. So we could record that for kids so that they could see 15 minus 6. 15 minus 5 is 10. Subtract 1 more, I'm at 9. Subtract from 10 is another strategy. And I'm going to share that again with the, in drawing it out. And so subtract from a 10 is a popular method in grade 1 curriculum. Again, based off of the base 10 system, kids have made 10s all through their schooling. So if we have a problem like 15 minus 8, we would break the 15 up and subtract the 8 from the 10. So we would have 2 and 5 would give us our 7, subtracting from a 10. So with our subtraction, we could think addition. We could go under 10, so make that 10 and then break it to go under 10. And our last strategy here is to subtract from 10. Moving on to multiplication. Multiplication has a few strategies as well. Some facts come a little bit easier than others. And those facts that we start with are doubling. We know since addition, doubling numbers, 5 plus 5, 6 plus 6 is easy. So we're going to start with times 2. And we help kids see that times 2 and doubles and how they relate. So 2 times 7 and relating that to 7 plus 7. In kindergarten, we count by 5. We skip count, 5, 10, 15. So we'll move to working with 5s. Zeros and ones are easy in multiplication, but we have to make sure they don't mix it with addition concepts. So when a student thinks addition with 0, 0 plus 5, 5. But with multiplication, it turns into 0. So really making sure they have the conceptual understanding of 5 groups of 0 and how that becomes 0 versus giving us a product of 5. The same idea with 1s. So we know 2s are easy, 5s, skip counting by 5s, and then we'll work with our 0s, 1s, 9s. 9s create a little challenge for kids, and this might seem like a trick to some, and we would challenge our kids to find out why in a base 10 system this would work. What I'm referring to here is you can see the facts, 1 times 9, 2 times 9, 3 times 9. If a student's struggling with 9, I'm going to help them see the first factor, 2, and how it relates to the first digit. So 4, the first digit is 3. The factor 5, the first digit is 4. The factor 6, the first digit is 5. If you then add those digits, 1 plus 8, you get 9. 2 plus 7 in the product, 27, gives us 9. 3 plus 6 is 9. So we can have kids use patterns to help them remember their 9s, but again, that's not a trick. It's based on our base 10 system in place value, and so there's a reason why that works. Have kids play with that and figure out, why does that work? I had one child once show me with their fingers a way that they could learn 9s. And they would say 9 times 1. They would put down their first finger, and that would be 9. 9 times 2. 9 times 2 is 1 and 8. Maybe in your way, 1 and 8. 9 times 3, 2 and 7. 9 times 3, 3, 6, 36. 3, 6, 36. Again, some may think that's a trick. It actually is based off of place value. So trying to understand why that works would be an interesting challenge for some kids. In multiplication, we really want to get kids to figure out for themselves what's hard for me, and then use what we call a derived fact. So on the screen here, you can see 7 times 3 was hard for this child. So we would use arrays. An array is this arrangement of the yellow counters here. And the student would say things like, 7 times 3 is hard, but I know I could break it into 4 times 3 and 3 times 3. So I could figure it out. And then on the board here, you could see different ways to help a student figure out 7 times 3. We don't need to do this with all facts, but with facts that are hard for us, we're giving kids tools to help figure them out. Because trying to count 7 on your fingers is an inefficient strategy and will lead to mistakes along the way. So with multiplication, we're going to use the facts we know, 2s, 5s, 0s, 1s, and 9s, and then the derived facts to help us figure out the rest of the facts. Division, we want to think multiplication, just like with subtraction. So 21 divided by 3 might be hard. So I'm saying, what's the missing factor? 3 times what number will give me 21? So that's phase 2, what Brody was talking about, those reasoning strategies. We can't go from build it counting to just know it. Some kids can make that recall, but others, there's facts along the way that are harder, and we have to build tools in a toolbox for them to reach to, because if they have nothing to come from, we're going to go back to those counting inefficient strategies. So what are keys for success? Number 1, we need to get kids to be independent and self-monitor. Somehow analyze what is hard for kids. Let them see, like here on the screen, charts. These are fluent facts. These are facts that are not fluent. And then what are some strategies we could use? Let's pick 2 facts that we're going to work on. We're not going to try to conquer all of them at once. We'll have kids self-monitor by maybe in journal writing. Say this fact is hard and this is a derived factor. This is the way I'm going to help myself remember it. One strategy is taking this multiplication or addition chart and having kids Let them use that chart, and week by week, or maybe every 2 weeks, start crossing out some of those facts so that they would cover them up as weeks go by, and they would first take out the ones that are easy, and then it would be left for the ones that aren't so easy. What other things? We want kids to focus on self-improvement. So what would that look like? It would be providing them with little goals along the way. They don't have to know all their facts, but what are the fluent facts? So as you can see on the screen here, different ways you can tell kids you're fluent, you're 70% fluent, you've mastered 25 new facts. Give them certificates for small gains. They don't have to know all their facts at once. Time. Recall is up to 3 seconds. It doesn't have to be immediate. Practice in shorter segments, no more than 10 minutes in a sitting to practice facts. Differentiate. Kids are going to be at all different levels. Don't work on just 1 week we're doing the 2s, the next week we're doing the 3s like I learned. Match up certain facts together. Allow kids to understand what they don't know and then build off of that. And be a guide. Use the guide that Barody's providing us. Are you in phase 1 with the students, phase 2, or phase 3? Phase 3 is that mastery level phase. So really with math facts, you want to make it fun. Kids have to enjoy doing this. So how can we make it fun? Use technology. I'm going to share with you in a little bit a site that's a great site for practicing facts. Games. So what are those games? We can play bingo. Bingo, take the bingo board, fill in the empty spots on the bingo board with products or sums. And then flip over a card, call out a fact. Have the kids see if they can locate that fact on their board and cover it with a chip. We're looking just like bingo to get so many in a row, horizontally, vertically, diagonally, and call out bingo. They're so close. 3 times 10. Yes, 3 times 10.
No. I put it down somewhere. Oh, come on. I don't have that.
We can work on games like concentration, where we take matches, and we might have the product and the actual expression. And the kids would turn 2 cards over and try to make a match. You can use the same idea with pictures, where you turn over a math fact and then try to find the array that would match that. So concentration, put them all out there, have them flip 2 over, find a match. You got a match. Ryan's got 3. We can play games like the product game, where you have a 6x6 grid, and either the students can fill in all the products from 1 to 9, or you can already have it filled out for them. Player 1 places a paperclip on one factor. Player 2 places a paperclip on another factor, and then places a chip on that product. The goal is to get 4 in a row. The strategy is to try to block your opponent. So as they move the paper clips, different strategies will evolve on where should I move it so that the player or my opponent can't win.
Blocked him. Good job.
Games like Old Maid, where you have matches. You distribute all the cards so that the kids, or all players, kids, adults, grandparents, all have the same amount of cards, and there's one Old Maid. We called it Spiky. So you would hold up your cards, the player next to you would pick one and see if they could make a match. If they made a match or they have any matches, you'd lay them down. So you'll see students or players putting down matches. The goal is not to be the last one with Spiky in your hand. So players will move one at a time, pick a card, find the match, and lay it down. Games like rocks, paper, scissors. We have 0, 1, 2, 3, 4, and 5 with our fingers. On the count of 3, we would shoot. You could do addition, where the kids would have to say the sum of those 2 fingers. You could do multiplication, where they would have to say the product. You could extend that to 2 hands and do facts of 10. So 10 and 3. Multiplication, somebody would shout out 30. The first player that shouts out the product or the sum, depending on the game, gets the point.
Shoot.
25.
Tie. You could play games like Salute. We have 3 players and a deck of cards. One player would be the saluter. The other 2, on command, would take a card and hold it to their head without looking. The saluter then would look at the 2 numbers and say the product of your numbers is, or the sum of your numbers is. Each player would look at the other person's number and figure out the missing factor, or the missing add-in. Once they got good with this process, you could extend it to a next level where they ask 2 questions. So it could say the product of your number is 2 less than 10. So they have to think 2 less than 10, and then they have to determine the product, and then figure out the missing factor.
The product is 2 more than 10.
2 more than 10.
I'm 3.
I'm a 4. All right, good job, guys. Greg Tang has some great games. One of those games I like is the web bonds. You can use web bonds. It's fact families with part whole relationships, where kids roll die and they fill in a circle and they try to make it a true statement. So the 2 parts will equal the whole. If it's a true statement, they outline that triangle and claim it by placing their initial in it. Another Greg Tang game that our kids like is Kakuma.
6, 10, 16. Yeah.
All right, next one. Kakuma has some hexagons around, and they have to try to find the fact family. So we use bells, which sometimes gets loud, and a student will yell something like 13, and they'll tap the bell, and they may see the 6, the 7, and the 13 on the same card. You can flip those cards over, and there's a square or rectangular arrangement. Same idea, where they have to find the family. So some with multiplication, and there's cards with addition as well. So the player would claim that card if they were the one that called out that fact family. So games are a really important part in making the recall process enjoyable, that practice. You can differentiate by the cards that you put in the decks, by the numbers that you use, whether it's 1 hand or 2 hands. So there's lots of ways to differentiate. You can have kids realize which facts are hard for them and put certain facts in the deck so they have to think about those strategies and use them again and again. So modifications on games may be necessary depending on the students that are playing the games as well. And games should be encouraged to be played at home, around the table with family members as well. So we make learning math facts and getting that recall fun by games. We also learn by technology. Technology, one of my favorite pieces is Reflex Math. Reflex Math allows them to create avatars, and it's game-like. Kids don't understand, they're working with math facts. It is differentiating and helping kids see where they're fluent and not fluent. So you'll get charts like this, as you can see here, and students will say, oh, I'm really struggling with my 12s, the 5 and the 7. So what's a strategy I could use for 5 plus 7? Maybe it's 5 plus 5 and then 2 more. So I'm going to help the student figure out what's hard for me and work with those strategies and reason some tools for that. Last question, what if we get kids that don't know their math facts? The worst thing you can do is drill them. They've been drilled for years and they haven't figured it out, so I don't know why you think drilling them more is going to help them. They need to go back to the reasoning. Start slow. Pick a few facts, work with them on those strategies. Analyze which facts they're having trouble with. Watch how they're solving their facts and use those strategies to help them learn their other ones. Teach less, learn more. All in all, math facts, yes, at some point they need recall. We need recall to teach perimeter, area, fractions, higher level math. We can't teach them in isolation or kids aren't going to have relationships between numbers. They're not going to see those relationships all on their own. So that's why I'm naming number relationships and guided intervention. You're guiding them through this process by the way you're modeling it. Tell them stories, model. We've got to play in 2 weeks. How many days is that? How could we write that? What's a strategy we could use to solve that? Move from counting to reasoning and then to mastery and recall. Take some advice from Art Borody and we're going to find much more success in mastering math facts.